Regenerative braking system. Regenerative braking is one of the key features of electrified powertrain systems, which enables vehicle to increase its fuel economy and driving range while reducing the carbon footprint to the environment. The recovery of the stored energy of the vehicle during braking is the fundamental concept behind the regenerative braking. During the braking phase of the vehicle, the electric machine acts as generator to convert the kinetic energy of the vehicle to electrical energy and store it in the onboard storage device. Typically, advanced batteries like lithium-ion batteries, supercapacitors, and flywheels. The energy can be used for consequent acceleration or driving the vehicle. Depending on the storage availability and the power torque handling capability of the electric machine, the regenerative braking efficiency of the powertrain system varies. The regenerative braking system. The process of utilizing dual braking system for braking is called brake blending, and precise brake blending is important for braking performance and for fuel economy achievement. The blending factor is defined as the ratio of friction brake torque over the total brake force demanded by the driver. Hence, it gives the fraction brake torque for the total force demanded by the driver. It is a friction brake torque. It is a complex function of brake pedal input, vehicle speed, safety events, and mechanization of the specifications. The regenerative brake torque command to the powertrain is the difference between the total brake torque and the friction brake torque. Figure shows the principle of regenerative braking system. As shown in the figure, the desired friction brake force is determined from the total brake force demanded by the driver and the blending factor subjected to the powertrain regenerative brake capacity and vary dynamically. So here we can see the brake pedal is given as the input, and also brake pedal force feedback is also given, and vehicle input is also there for the regenerative braking system. It will be given to the powertrain regenerative braking torque command. It will generate it, and it will given to the hybrid electric powertrain. The hybrid electric powertrain, then it will provide the regenerative braking to the wheel, and also it will give generated power to the high voltage battery power. In the regenerative braking, it will also have the facility of friction braking system, and brake pad clamping force will be applied to the wheels. So desired friction brake torque, desired brake pressure, and actual brake system pressure, these parameters are there for this system. The dual braking system is used into the while regenerative braking is applied. So there are various reasons for having the dual braking, that is the regenerative braking as well as the friction braking. First, the fluctuation in braking power demand and torque power limitations of the electric propulsion system. So there can be different type of braking. It may be mild braking, it may be medium braking, and heavy braking. During a mild braking event, the braking power requirement of the vehicle will be much lower, and this can be supplied by the electric propulsion system. That is, a pure regenerative braking will be there when it is a mild braking event. Braking power requirement of a medium braking event is much higher than the mild braking. In medium braking condition, regenerative braking capacity of the vehicle is mainly dependent on the percentage of the share of electric propulsion system in the powertrain. In heavy braking, it may require the blending of this regenerative as well as the friction braking. Second limitations or second reason for dual braking is the operational characteristics of the electric machine and its influence. Torque capability of the electric machine in generating mode is highly dependent on the rotational speed of the machine, and this capability may decrease when the machine runs at low speeds. Electric machine and the inverter have poor efficiency at low speed braking conditions. Therefore, friction braking system must be employed at low braking events or speeds, low speed braking events. Then reason for dual braking is the limitation of energy storage system. Not only the energy storage device limit the regenerative braking, but the power torque handling capability of the electric machine and the power tonic system also act as the primary limiting factors in regenerative braking. It is possible to design an electrified powertrain system to handle all kinds of braking requirement, but it cannot be accomplished without weight, volume, and overall cost increment of the vehicle. So regenerative braking will increase the weight, volume, and cost of the vehicle. Therefore, to achieve adequate regenerative braking performance within the realistic limitations, dual braking system is required, which can keep the weight, volume, and overall cost in a required limits. The fourth is weight distribution and braking dynamics. The center of gravity of vehicle and its location related to the front and rear wheels are very important in braking performance. The variation of normal force distribution with respect to the deceleration rate is known as the dynamic force transfer. The energy recovery efficiency can be significantly improved by integrating electric drive systems in both axles. The applicable braking force on a given terrain in a given wheel is proportional to the normal force acting on the wheel. Therefore, by knowing the normal force, the braking force distribution is obtained. Braking system in electrical vehicles. The braking system of electrified vehicle is controlled by the braking control system, which operates depending on the expected deceleration requirement of the vehicle. The primary objective of the braking control system are to maximize the involvement of regenerative braking system or any given braking condition. Second, to ensure that the expected braking torque is provided to achieve the expected deceleration requirement in safe manner. Also, achieving braking feel is one of the key design challenges in the braking control. So the regenerative braking should be a smooth, and that is achieving the good feel of the braking. So those two factors are important to maximum regenerative braking, to achieve maximum regenerative braking and provide the expected braking torque. Regenerative braking and friction braking power flow. The braking power is shared between the front and rear wheels. If we consider a front-wheel drive hybrid electric car with regenerative braking, as shown in the figure, braking power of the vehicle will be braking power at the front wheels and braking power at the rear wheels. Now, considering the front wheel is the drive wheel, that is a front wheel driven vehicle, then the braking power at the front wheel will have friction braking facility as well as regenerative braking facility, which is called as the blending, or it is a dual braking system. And at the rear wheel, it will be braking at the rear wheel, which will be the friction braking. Braking power is shared between the front and rear wheels as shown in the above diagram. Since the front axle is integrated with the regenerative braking system, part of the front axle braking is achieved by regenerative braking system as well as friction braking system. A friction braking system is employed for the rear axle braking as shown here. Force torque acting on the braking wheel can be seen in this diagram. Considering A as the acceleration rate, FVW braking force acting on the wheel is the FBW. FBG is the braking force acting on the ground, which is shown here. TBW is the braking torque, which is shown here. The constant braking force FBW should act on the wheel, which is equivalent to the force exerted by the wheel on the ground, FBG, for the vehicle to achieve a constant deceleration rate A. To generate a constant braking force, the torque generated by the braking system TBW should be constant and equivalent to FBG. Regardless of this, the torque generated by the electric propulsion system is highly nonlinear and varies with the operating speed of the electric machine. Therefore, to achieve a constant deceleration rate, the dual system must be blended together in an optimized way, which maximizes the utilization of electric braking while supplying the excess braking power to the friction system. We can see here an energy storage for regenerative braking system, taking the example of pure mechanical flywheel system. The flywheel system stores the recovered energy of the vehicle in the form of kinetic energy, while supercapacitors store it in the form of electric energy. Transmission system connected with the drive axle is directly coupled with the mechanical flywheel. The speed difference between the flywheel and the drive axle must be managed by the transmission system. Now here the flywheel is connected to the transmission system and which is connected to the drive wheels. The transmission system design is one of the primary challenge when pure mechanical flywheel system is connected in this particular design, and it is still in early stage of development. With less number of energy conversions, this design achieves higher energy recovery, considered as one of the primary advantages of this design. So we can see here that the drive wheel and the flywheel are connected to the transmission line. Now, during the acceleration of this vehicle, the energy of the transmission will be stored into the mechanical flywheel. So diverting the energy to the flywheel and reducing the speed of the vehicle. Whenever there is requirement of the energy, The flywheel, which is connected to the transmission, can supply the stored energy to the wheels. So this is the mechanical flywheel as a regenerative energy storage. Second, the flywheel has a regenerative braking energy storage. Now it is the form of electrified, or it is the electrical system which is connected to the flywheel. In this system, we can see the drive wheel, the transmission. Now here, instead of connecting the flywheel directly, it is connected via electric motor and powertronic converters. So this is the electric flywheel system, electrified flywheel system. So whenever the vehicle is deaccelerating or regenerative braking is applied, the energy will be transmitted to store in the flywheel in the form of electrical energy, as it will be converted to the electrical energy by the electrical motor, because now there will be generating action, and the generator will give energy to the flywheel, and flywheel, this motor will run and it will give the kinetic energy. Now while requirement of the energy, this flywheel will convert this electrical energy, mechanical energy into electrical energy, and that will be given to the electric motor, and that will support the transmission system. So there is the flywheel always will convert the electrical energy back to the electrical energy, and it will given to the motor, or in another, the electrical energy will be given to the flywheel, and it will be convert the electrical to mechanical. So this is the electrified flywheel system. So in the contrary to the pure mechanical arrangement, this design uses an electrical machine to recharge the flywheel system. It is through the electric machine. The recovered electric power from the electrified propulsion system will be transferred to the electric machine via suitable power regulations during the braking phase. The primary advantage of this design is it can be easily incorporated in any existing electrified vehicle. However, the higher number of energy conversion, this has reduced overall efficiency. A figure shows the supercapacitor-based regenerative braking system. Here, electrified flywheel system has been replaced by the supercapacitor bank. In this design also, the conventionally integrated in electrified vehicle, it suffers from a higher number of energy conversions. We can see the motor, drive wheels, which are coupled to the transmission. They have the electric motor generator system connected via this powertronic devices to the supercapacitor. Now during the discharging phase, or when supercapacitor supplies the input which is stored during the regeneration, it will given back to the electric motor. Electric motor will coupled to the transmission and give input to the wheels. During the regeneration, the energy which is recovered is given to the electrical generator, and this generator will charge the supercapacitor. So this is the way charging and discharging of the supercapacitor will occur during the regeneration. In terms of specific power and power density, battery systems are inferior to supercapacitor and flywheel systems, and therefore batteries are not good candidate for these applications. However, battery systems are also used for these applications with appropriate design of power and energy management systems.